Hello, am I audible? Yes, it's 1:30 p.m. Good afternoon, all. Jalpan sir, can we start?
Yes, we can start.
Okay. Okay, so good afternoon, all. I, Ronak Vasi, working as an assistant professor in BVM Engineering College, welcome our today's speaker, Mr. Jalpan Parekh sir, Senior Embedded Engineer at System Level Solution India Private Limited, and all the participants. Jalpan sir have more than 6 years of industry experience in various industries in the field of IoT gateway SDK, E2E communication, which is based on FreeRTOS. Even he worked UK-based smart metering emulator project based on a Zigbee technology, smart healthcare product during this COVID pandemic situation, which is the scan temperature based on face recognition. He is also worked in weather radar controlling system, which system is deployed in Guwahati. Once again, I welcome you, sir. Now, I hand over the session to you on IoT case studies. Please, Jalpan sir.
Thank you, sir. Thank you for inviting me for as a speaker. Okay, I'm sharing my screen. Is it visible?
Yes, sir. It's visible.
Okay. So myself, Jalpan Parekh, I'm a senior embedded engineer in system level solutions. So basically, I have worked on various projects. So mostly projects are on IoT based. So today's sessions will be on the IoT use cases. So there are various IoT use cases available, but won't be able to discuss all the IoT use cases in one session. So today we will discuss few of the use cases. So today's agenda is smart parking system, smart healthcare, smart farming using IoT, highlights of IoT statistics, and top 10 IoT application areas in 2020. So first we will go with the before moving ahead for the smart parking systems, I would like to also repeat the same thing as I have repeated yesterday. Like in 2016, there were more than 4.7 billion IoT devices are connected to the internet. And according to the analysis, it will be more than 11 billion devices will be connected by 2021. And it will be around 2020 it will be around 21 billion devices by 2025. So think like how many application uses this IoT devices. So there are a lot of applications will be there to use the IoT devices. So smart parking system. So nowadays you can see this image. It's a parking problem. So nowadays you want to go outside, so in your personal vehicle. So first thing comes in your mind: will I get the parking? Where I will park my vehicle? So I think nowadays the parking is the biggest problem for the crowded places, like well-known social places, railway stations, airports, type of places. So This, so to overcome this, smart parking system is implemented. So let us take with one example. Everybody is well aware with the international airport Ahmedabad, right? So everybody went there. So just think like you are going to there in the December and January month, where mostly NRIs are traveling. So that place is too much crowded. So definitely the parking area is also crowded. So what happen if you are going to park your vehicle enter into the parking area where you don't know where you will park your vehicle, because there are very less free parking slots available. So there are almost 7 to 8 rows, and in each rows there are two sides, and each side's having the around 25-30 vehicles, even more we can park. So you need to go row by row and to check which free parking slot is available. So I think that sounds some tedious jobs to do. So it will be harder for us to find a free parking slot. So now just think, what if a smart parking system is implemented there? Then then you enter. So now you are entering into the airport. So entering into the parking area. Even you are before entering into the parking area, you will get to know where you will park your vehicle. So you opened your mobile applications. Where is Google map is there, which shows this some green dots or something indications which shows the where this is the place where you can park your vehicle. So you just directly go there and park your vehicle hassle free. Or also you can see in front of screen at the airport, which shows that this row has this many free parking slots available. So in short, that becomes very easier for us to park your vehicle. So parking systems become very easier. So how this will work? As we have seen the basic functionality of the smart parking. So how this will work? So as I have divided the smart parking systems into the 5 components. First one is ultrasonic distance sensors, battery operated nodes, IoT gateways, which gives the connectivity, a cloud or server, which manages your data, and a web application or mobile applications, which is nothing but the user interface. So first one is the ultrasonic sensors. What is the use of ultrasonic distance sensors? As the name suggests, ultrasonic distance sensors use is to detect the presence of car, as that car is present or not. So its main work is to detect the presence of car. So there are various parking slots are available. So each and every parking slots having this sensors. So that detects the presence, and that sensor is directly connected to the battery operated node. So that battery operated node collects the data at every certain interval. So that captures the data at every certain interval and send it to the other device. Now you can see that I have used word battery operated node or battery operated device. Why I'm calling it as a battery operated? Anyone have idea? Why we are taking it as a battery operated? Sorry.
Contactless.
Means
Without wired harness.
No, it is tiny and requires only low power.
yeah, right.
I think it provides flexibility.
Yeah, means you are making smart system. So just think like if you are making a smart system, and there are, as I have said, there are so many parking slots are available. So each and every slots having this battery operated node. So now you think like if you are making it as a main powered, so then how it would be difficult for the installation. Even if you are making it underground, then still this will be more difficult to install it. Right. So that would be great if we can minimal the wired. So don't look at messy, and it won't be harder for the installation. Right. So as we have taken the battery operated node, so we need to think like we need to use some protocol which can transfer data to the other device. We have to choose protocol which consumes the less power, right? So which IoT protocols we will choose to transfer the data to the other device. So I think Zigbee is the good one, best one, best approach here, which using which we can send the data to the other device. So why we use Zigbee? As I've said, it is a low power consumptions, so your device has a longer battery life. Its cost is also very low, because cost is the also the main thing which need to think in a whole system, because we need to use the various devices in the whole smart parking systems. So cost is also the matter. Its cost is around I think 700 per module. If you are take it in a bulk, then per module cost is also reduced. It supports multiple nodes. It supports multiple nodes. It means you can connect in a Zigbee network. Zigbee is a personal area network. I'll just brief you about the Zigbee again. It's a personal area network. So there are three types of entities. One is the coordinator, one is the end device, and other one is the router. So coordinator's job is to create the network. So it is very similar to the creating the hotspot, Wi-Fi hotspot we are creating. And the station device is joining the hotspot device. It's a access point, joining the access point. So same thing here, coordinator is creating the network, and end device and router is joining to the coordinator. Router's job is to route data which is not in the range, which device is not in the range. So here we uses end devices as a node. So this is the end device is nothing but a battery operated node. So that's why I would say, so Zigbee having a support of around 240 nodes, ideally we can connect, but still this number will be based on the testing only. And if you use it to 2.4 gigahertz Zigbee, so that's ranges around 100 meter. So I think that's 100 meter. It's I think enough. If the parking slot is parking area is bigger, then you can also use the sub gigahertz chip, which is ranges around 1 kilometer or more. But the data rates is lower. But I think in our case, in the parking systems, it would be enough, because we don't need to send much data. So that's why we choose Zigbee here. So now the next one is the now you have sent, now your battery operated node have sent data to the IoT gateway. So IoT gateway captures the data. So IoT gateway understand the Zigbee technology, definitely, right? Because a node, these are the nodes which sends data over Zigbee technology. So at the same time, IoT gateway also understand the Zigbee technology. So now, what is IoT gateway? IoT gateway is nothing but a language converter. In the technical terms, I can say it's a protocol conversion. Like there is one Indian and Chinese person wants to talk with each other. Then how they will talk? They don't know each other's language. So they need some medium, right? So which knows both the language, that medium as a person or any application. So that medium has to use it. So let's put it in our case, IoT gateway can communicate with the IoT devices, which is the battery operated node. And IoT gateway can also communicate with the middleware or server, which supports some different protocol. And the node supports some different protocol. So it converts the data, taking the data from one device, which supports different protocol, and pass it to the other device, which supports some different protocol, right? So this is the IoT gateway. IoT gateway gives the connectivity into the network. So it has if IoT gateway wants to send data to the server, or you can say middleware, then it has to be capable to connect with the internet first. So it should have some capability like cellular network, Ethernet, some Wi-Fi module. So it's giving internet connectivity. So now you wants to send data to the server. So there are various protocols we can use to communicate with the server, like HTTP, HTTPS. It's a secure communications. Same way, WebSocket secure. Sorry. And MQTT, Message Queue Telemetry Transport Protocol. MQTT is very widely used protocol. Most of the companies using this MQTT protocol. So we also use this protocol in the smart parking systems. So why we should use this MQTT? So before moving for the why we should use, I'll explain you the MQTT, basic about the MQTT. MQTT has a three types of component: uh, publisher, subscriber, and MQTT broker. MQTT broker is nothing but the server. So now some sensor sends data, so it means it publishing the data to the server, and at the same time MQTT broker decides how many devices has subscribed on the same topic which publisher has sent that data. Understood? How many devices have subscribed on the topic? Topic means there is one channel, on which channel that publisher has sent the data. So it checks that how many devices have subscribed it, and it sends data to that subscriber. So let's put into the our application. So our sensors data, battery operated nodes capturing the data at certain interval, and it passes those the data to the IoT gateway. Now IoT gateway sends the data to the MQTT broker or MQTT server. It means IoT gateway publishing the data to the MQTT broker, and MQTT broker now decides how many applications have subscribed it. It means in our case, who have subscribed it, who is having, suppose you are entering into the parking area, so you opened your mobile application or your any web applications, then you are subscribed it, then your device, your mobile application have subscribed it, so the mobile application is subscriber. So at the same time, if there is a screen in front of you at the airport which shows the free parking slots, is also the subscriber. So subscriber means receiver, who is receiving this data. Hope you understand. So why we use MQTT? Gives bandwidth requirement to it absolute minimum, handles unreliable network, require little implementation effort for developers to develop it, and therefore ideal for machine to machine communication. Okay, so this is what the MQTT, that is why we have used MQTT in the smart parking system. So last one is the web application or mobile applications. As we have discussed, the last component is the user interface. The user, in this case, in the smart parking system, user interface just monitoring the data, not taking any action. It's not controlling anything, because we just need to monitor it and just check it where is the free parking slots available. So it can be on a web application or on a mobile application. Okay, so before moving forward, I would like to ask you one question. Like, why we use IoT gateway here? Anyone? can't we directly connect with the cloud? Can't our sensors are directly connect with the cloud?
Not possible. Because the
Why?
thing is that the gateway is the device which connects either in the format, whether you require TCP/IP, UTP. It's like a gateway which is arranging the data such that web application or mobile application or mobile browser can directly access the IP of that device. So that streamlines the gateway streamlines one form of data, which is whether it is in the raw data format available from the sensor side, whether it is in one stream, it is converted to the stream which is usable to the UI UX per se.
So you are saying like data is directly sent from IoT gateway to the user interface, mobile application?
The data is sent to the some server or maybe some computer which is accessing the data. For example, we are in the parking, the example which you have given, the parking, the smart parking. The smart parking data is whether it's a processor, the processor process the data. The data is available in one kind of form, and that data need to be transmitted through small controller to the main server. And that for that you need to have some device which streamline the data in the form at which you are connecting your gateway such that that gateway connects with your network, whether it is a LAN network or whether it is your whichever the wireless form. So you will be, if it's a wired network, you will be accessing through the wired LAN in the IP form, in the TCP IP form. If it's a wireless, then you can directly transmit through the wireless network out of the gateway.
No, what I'm saying, can't we make a node capable to send it directly to the server? Why cannot make our node capable to send it to the server? We can make it, right?
No,
Can't we implement?
like a mobile apps you are accessing either local IP or global static IP. It's a IP you are accessing. That IP is the one kind of device accessing the device.
That's what I'm saying. Can't we make it capable? I'm not saying that I'll use that battery operated node and whatever, but can't we make it capable of our battery operated of our node to send it to the server?
No, it is because the transmission power is very less. It cannot reach the cloud. Say in the node, actually, we use only ZigBee.
No, that's what I'm saying. Just now you want to make your node capable to send it to the server. So just forget, like, you won't use ZigBee. ZigBee is for the local area network. So you won't use ZigBee because cloud don't understand ZigBee. So cloud understands TCP, IP, UDP, HTTP. So those protocols they are understanding. So if I will use those protocols in my node, then can I send directly data from sensors to the cloud?
It consumes a lot of power actually. So the reason for going for battery operated is ZigBee, it is low power protocol. So if you use battery operated device, then using TCP and all, it is difficult. It will consume a lot of power. So I don't think
it's like that. We are accessing the physical layer and transport layer. Okay, and the gateway provides the media such that we are able to connect to the enterprise layer. If we talk into levels of ISO layer, so
no, it's not like that. We can previously he has said like main power consumption. That is the one of the main thing is power consumptions. Else we can make our node capable to send it to server. If we uses TT there, then definitely we can send our sensors data to the server. But what are the reasons are there? I'll tell you. One of the reasons is the power consumption. Right. If you want to send data to the server. So you required internet. It means you need some module, GSM cellular module, you need Wi-Fi module. So that cost is higher. Now you think there are how many devices available in the parking area. So there are so many devices are available in the parking area. If you make it capable each and every devices to connect with the internet, so I'll use GSM module to each and every node, right? So that would be that having the so much cost. So instead of that, I'll use Zigbee here. So Zigbee, that chip cost is also lower. Even it consumes less power. And if I'll use the cellular network, then I need to make that node as a main power. Else I need to recharge my battery at certain times continuously. I mean, so it will be very difficult, and my power consumption is also higher. So that is why they choose some technology, so that can consumes less power. So for that we need some medium which can directly communicate with the server on the external network, also also with the local area network. So Zigbee is for the local area network. Okay, hope you got it. Okay, so let's moving ahead. So next application is smart healthcare. As there are various smart healthcare devices, IoT devices are available, but in which we will use the scan temperature. We will discuss a scan temperature device because sorry, as COVID-19 time is going on, so I think this is the best one to discuss it here. Now, what is the so how many temperature scanning devices available in the market? Can anyone? How many temperature scanning devices available in the market?
So many, starting from Borden tube, RTD, thermistor, thermocouple, pyrometer.
20.
So many.
No, means I'm talking about the direct IoT device, like a thermal gun, that type of devices.
So temperature.
Thermometer.
Yeah, it's like a
Thermometer.
Borden tube is a thermometer. It's a Borden tube.
Okay.
Infrared,
Okay.
higher temperature than.
Okay.
First of all, you need to ask them whether you are asking for contact type or contactless type.
No, I'm talking about general. How many temperature scanning devices available?
No.
You make it as
There
a
are plenty of temperature sensors.
Don't generalize the things. You will be in trouble. That's why.
We cannot count the number actually, no. Unless otherwise we are
Just
specific.
yeah, tell us.
There is no specific number actually. I
No,
don't think there will be a specific
I'm not
number.
asking the number. I'm not asking the number. The device name, like a thermometer, like a thermal gun, thermal cameras.
That's what we decided. RTD is a thermometer, resistance temperature detector. Is a thermometer. The Borden tube is a thermometer. Borden tube is a thermometer. One kind of thing.
Okay. Else? Thermal face recognition. You have heard that? Thermal face recognition. Scan your temperature based on face recognition with the help of face recognition. So that nothing but use the IR temperature only. Okay. So today we will discuss about the thermal face recognition biometric scanner. So there are, as I've said, it's definitely due to COVID-19, we need to make some device is contactless. For that, same here, it's we can call it as a 100% hands-free hygienic user authentication systems. So just think like you are just giving you brief idea about this how face recognition system works. So just think like you are working in a company, and your admin department has insert data. Uh, some noise. Someone's camera. Can you mute it? Okay. Okay. So just think like you're working in a company, and your admin has initially insert your data during the installations. So in the data, your admin has taken your photograph, employee name, and employee ID. So they have inserted into the device database. Now, next time when you are step up for the scanning, so just so first it detects the uh, face detections. Once it detected the face, why it is face detections? Because it cannot detect your any part of your body. If you take your hand, come across the device, it won't detect your hand. So once it detected the face, it goes for the face recognitions from his database. So in parallel, it starts scanning the temperature of the person in front of the scanner. Once it recognize the face, it display on screen like a monitor. It's display the employee name with their photographs and employee ID, and also the temperature. So in parallel, it also sending to the remote applications. So anyone, your admin or HR can monitor their employees' data remotely from anywhere. So this is what a basic how face recognition works. So in which one thing I forgot to add. Suppose if your temperature is in the normal range, then the device is having the facility to operate some relay. So it opens the door, and you can enter into the company. Now, now suppose think like your temperature is not in the normal range and you have a fever. So it definitely won't open the door. And at the same time, your data is also sending to the remote application, web application, mobile application. So your admin will get the one warning email or any text message, so that they can take the further action on it. So this is how the whole face recognition system works. So from this, I would like to add some points here. We won't discuss how you will send data to the server, because in the last application we have already seen the MQTT. How the same way we are also sending the data, we can also send the data to the server. But here few things I would like to share with you is how it recognizes the face. So this slide is for the face recognitions, how that will recognize your face. So 60,000 points of accuracy. 60,000 points of accuracy. It means that scanner will detect your 60,000 biometric points of your face. So as I've said, during installation, your admin has stored your photograph and your name and ID. Along with that, that device has also stored the 6,000 points out from the 60,000 points. Total 60,000 points that scanners can detect. From that 6,000 points, it will be stored into the database. See, there are nothing but the biometric points of your face. So mostly it will take it your cheek and your jawline's points. So it will be easier for the detections. So when you next time when you step up for the scanning, so it will matches at least 60 points and recognize your face. So I think 60 points sounds too low, but it will be enough to differentiate uh, individuals. Even it is enough to differentiate twins. So this is how face recognition works. Mask detection and reminder. The device having the facility to detect the mask you wore the mask or not, also gives you the reminder to wear the mask. Okay, so one more thing we have used is the infrared temperature sensor. As this is the contactless, so we will use the IR sensor, IR temperature sensors. So I would like to give a brief, the basic working principle of IR temperature sensor. You can see that when the sunlight strikes to the object here is nothing but the person. So when the sunlight strikes to any object, it produces different types of energy, in which one of the energy is the infrared energy, which human cannot visible it. So how much amount of energy it produces is totally based on the temperature of that object. If the temperature is higher, that produces more infrared energy, lower, then less. Now, if it produces the infrared energy, now if you measure this infrared energy with some detector, IR detector, then it is possible. Then it is possible to measure the particular object's temperature. So with the help of lens, so you can see here the lens. So whatever the IR radiations, IR rays produce, it detects to IR detector through this lens. It can focus through this lens. So this IR detector are nothing. Detector is nothing but nothing about the thermopile. So based on the presence of thermal energy in the IR rays, your thermopile starts heating, and it gives the output as electrical output signals. So later it will be converted into the digital signals using ADC and display it on and display your temperature on screen. So this is the basic principle of IR sensor. Advantages of IR temperature sensor. IR sensor reads moving object. Contact-based sensor temperature sensors do not work well on moving objects. If your objects are moving, then it won't work. Infrared temperature sensors are ideally suited for measuring the temperatures of tires, brakes, and similar devices. Air sensor don't wear as it is contactless. No contact means no friction. So infrared sensor experience longer operating lives. IR sensors can provide more details, and IR sensors can provide greater details during a measurement than contact devices, simply by pointing it at a different spots on the object being green. Some of the IR temperatures reads the 16 cross 16 matrix. So suppose if phase come across the sensors, then it detects the different temperature of your faces. It gives the 16 readings. IR sensors can be used to detect motion by measuring the fluctuations in temperature. So in whatever in that field of view. So it can also be used to detect the motion. So this is the thermal face recognition system. So let's see the third application, smart farming using IoT. Smart parking with the use of IoT, making it optimal, but also making it cost efficient for farmers and reducing crop wastage. Smart parking will assist farmer by getting the live data, temperature, humidity, soil moisture, UV index, pH level, soil's pH level from the farmland to take it necessary steps and enable them to do smart farming. It's been a long since sensors were already introduced in the agriculture operations. But the problem with the traditional approach of utilizing sensors technology was that we were not able to get them live data. So what is the traditional approach? As we have already the sensors available before the IoT. Then what is the problem? What is the actual problem that we were not using it? Can anyone?
Can
Yes.
you please repeat the question, please?
I said like yes, repeating. I've said like we already have the sensors for the agriculture. There are various sensors available even before the IoT comes into the picture. But why we are not using it? Why that sensors not in the trending?
Why the sensors are not trending?
Real-time monitoring is not possible.
Yes, right. How? Then what? How those sensors? They are definitely previous before the IoT. They have made sensors. Then definitely they have something. They can show the data of that sensors, right? Then what they have made? I mean, the main point is what is there in the sensors to show the data. As you have said, if the currently if you use it this agriculture sensors, then you can see the real time data, right? Then what happened before the IoT? Sensors are already there before the IoT.
Some kind of processing is required to decide on the sensed value.
Sorry, couldn't get you.
Some kind of processing is required to decide on the sensed value or captured value.
No, means what happened? I'll tell you. Previously, what they are doing, they just storing the data because at that time before the IoT, you cannot monitor your data live, right? So what they are doing, they are storing the data into some memory. So later on, they take that memory and read the data, but we cannot see it live. But after the IoT, you can see the live data and make a decision at the right time. In the agriculture, to make a decision, one of the biggest thing. So this is why uh, how how this store data into the memory. Okay, so some noise is coming. So with the IoT agriculture, far more advanced sensors are being utilized. Those sensors are now connected to the cloud via cellular network. So it means definitely some gateway kind of things they have used. So which let us know the real-time data from these sensors, making the decision and making it effective. Internet of Things in agriculture has come up as a second wave of green revolutions. So there are various types of sensors uh, uh, using in the agriculture. Temperature sensors to check the climate. Climate plays a very critical role for the farming, and having improper knowledge about the climate makes heavy losses in crop productions. But the climate monitoring sensors are placed inside and outside of the agriculture field. So they collect the data from the environment, which is used to choose the right crops, which is choose the right crop at the right time. So you will get the better productions and better quality. So second one is the sorry pH sensors in agriculture. Using the pH sensors provides critical feedback regarding soil's nutrition deficiencies or the presence of chemical in the crop. So this sensor is used for daily, weekly, monthly, and annually changing the soil pH level. So few more sensors are also used. Some of the sensors are accelerometer sensors, which is detecting not much useful, but we can use it. Accelerometer sensors for detecting the moving parts like a motor, if there is much vibrations or not. Or some of the people are using the smart cameras to watch their field. And in agriculture, they have used the cow detector sensors using LoRa. So there are many sensors they have used in the smart agriculture. So here is the few highlights of IoT statistics. According to McKinsey's IoT growth statistics, there are 127 new IoT devices connecting to the internet every second. Every second, this many devices are connected. So consumer electronics have installed 63% of IoT units in 2020. Gartner IoT Research claims that there will be 25 billion devices by the end of 2025. Intel IoT Research says more than 40% of IoT devices will be used in industry or manufacturing. McKinsey's IoT statistics says the Internet of Things market size is so big, it has the potential to generate 4 trillion to 11 trillion by 2025. There will be 1.9 billion 5G cellular subscriptions by 2024. So these are some highlights of IoT statistics. So how, as you have seen various IoT devices nowadays IoT devices number is increasing. So which IoT application nowadays having the mostly used in the market? Which IoT application? Like we have discussed, smart agriculture, the waste management, home automations, like that. Which applications is moving into the market? At least try. There are various applications. Okay, so I have some numbers here. Manufacturing and industry, 1.9 trillion. is the number, that the top 20. So manufacturing industries mostly preferring the IoT devices nowadays. Transport and mobility. Nowadays, transportations, automotive industries is more working towards the uh, being a smart. Energy, retailer, cities, smart healthcare, supply chain, agriculture, smart buildings, and the rest of the other applications. Okay. So I would like to give you one task. So in which you have to tell us how many sensors, what type of sensors we can use in the home automation, and which technology I will use for the smart home automation. Come on, guys, try it. Yes. Okay. First tell us how what are the sensors we can use.
Motion sensor.
You can speak.
Can
Yes.
use temperature sensors.
Motion sensor. Okay.
Proximity sensor.
Can use
Okay.
LDR.
Okay.
Yeah. Ultrasonic sensors.
Ultrasonic sensors for
Not.
LDR
I think
for detecting the light room lighting conditions.
Optical pickup, red contact.
LDR.
okay. Else, door sensors. I'm asking you in a general terms, not the exact technical terms we will use.
Gas detecting sensors.
Okay. Okay. Thermostat, so we can control the cooling of our home.
Humidity sensor.
Okay. Okay, so which technology? Suppose just think like you have this many sensors available into your home. So how you will connect those sensors? How you will get the live data?
using IoT gateway.
Using IoT gateway, you can give the connectivity and get the live data. So this is one side, right? So now how
Okay.
you will capture the data from the sensor?
Sensor,
Sensor have,
sensors, transducer, signal conditioning device, and signal conditioning device to the digital connection, digital streamline connection, connecting to the communication layer, transport layer, and then making in the form
no, 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 no.
gateway.
I'm talking.
No,
I'm
from the
talking about the
sensor, we
which.
can use node. We can use node to collect the data from the sensors, and the node can be connected to the IoT gateway wirelessly.
Yes. That's what I'm asking. Which protocol they will use to connect
Zigbee
with the
between
gateway?
Zigbee between gateway and the node and gateway. Using Zigbee, this node will transfer data to IoT. I mean the gateway.
Okay, Zigbee we can use. What others protocol we can use?
MQTT
Bluetooth?
can be used.
Bluetooth.
No, MQTT is for the communication with the server. So IoT, it is for the communication between the IoT gateway and the server.
Can use LoPan.
Yes,
LoRaWAN Bluetooth.
LoRaWAN. LoRaWAN
That
is
is
for the
long distance.
long distance, and I don't think so. Our home would be around 1 kilometer, 2 kilometer, right? So I think nobody will use that LoRaWAN. What else? BLE. You have heard the BLE?
What?
BLE. BLE. Bluetooth Low Energy. BLE.
BLE. Somebody said.
Yes. Yes. Say something. Bluetooth is also a low. That's a lower power version. It consumes the less power. I think in the wearable devices, BL is. That's why your smartwatch, the battery life is longer. Okay. So in short, we need to use some protocol which consumes the less power, and we don't have sensors here which consumes the which needs some more data. We have not if we not use the cameras, even we can use the cameras in smart home automations. Then that sensor is required, something Wi-Fi kind of protocols. So in short, your IoT gateway having the capability to support the multiple protocols, because some of the devices supports different protocols. Some of the devices like a camera Wi-Fi protocol, so your device needs Wi-Fi protocol, right? Okay, thank you. Any questions?
Yes, participants can ask questions to the sir.
Even if there are any image or video, can be compressed using compressive sensing and then can use Zigbee, right?
But you just think like you you are using the camera, so you are sending the live images, and live that camera supports some per second. How many? If you are making it compressed, then even that lower the data rates won't match. You will
No,
be
actually,
even lagged it,
oh,
because Zigbee has a very low data rates.
yeah, it is only
But
256 kbps, but
yes,
still,
yes,
compressive sensing instead of it is not compressing after collecting the data. While capturing itself, it will collect only the selected points alone is
but
captured, and it is sent
live,
it using 256, yeah, even for live, and it can be again uh,
You,
what is
you will
using
have
up.
issue during expanding the quality will deteriorate.
That is called as compressive compressed sensing. Sensing, instead of capturing all the pixels, it will select only the selected pixels, and that alone is sufficient to recover it back.
that you can do that, even you're compressing it, but then even you also have to think about it, still it will be manageable or not, because that Wi-Fi rate is we know that Wi-Fi rate, it's in the Mbps, and it's just in the 250 kbps. But yes, we can try
Yeah, but
it.
anyway, yeah, I have seen few research papers
No, no, no,
where
no.
they use compressive sensing. Using
I
compressive
have not
sensing,
seen that.
okay.
But yes,
Oh,
maybe definitely you have think it, that definitely someone have definitely think about it. Definitely, I will check.
okay, thank you.
Anyone? Okay. So thank you everyone. Okay, so I'm finishing this session here.
Yes, sir. Jalpan, sir. Uh, Thank you very much for the session, and based on different sensors information and IoT case studies. Now we will dear participants, we will meet at 3:30 sharp to the next session. Thank you very much, Jalpan, sir.
Thank you.
Thank you everyone.